Hello, everyone. Can someone just say something so that I could just want to?
Good morning, Chinmay sir.
Hello, sir.
So we'll wait. Let students join because many students are there from Africa, from Nigeria. So they are going to join soon. So once it will be 70 plus or 80 plus, then we'll start.
Okay, sure.
Everything is ready. So 5 minutes, 10:05 will start.
Yeah. Okay, sure, no problem.
So I have already made you the co-host, so you can share your screen whenever required.
I guess now also I can share the screen.
Yes. Two screens are there now. One. Okay, fine. Yeah. So at 10:05 will join. Just wait for another 5 minutes.
Yeah.
So
sure,
what about your holidays? Going on the summer vacation?
Summer vacation. Well, it's going on. So over here, it's almost like 2 months.
So actually, I have planned every year. I have to conduct two schools. Like your one is your summer school, another school will be there winter school for 7 or 8 days. So every year from this year only, I plan to continue every year. That summer school one will be there, and this time only before 7 days only I have got the permission. So that's why very weak. I don't have time to prepare all those things. But next time, before 2 months, we'll prepare for the winter school and we'll see what will be the topic that we'll see. And our main objective is how students can join for the internship. Those who have attended all the classes, means 70-80% sessions if they have attended, then our objective is to do some small projects so that that project can be converted later into some you can say the project work or research work. Okay, that is our objective. So let us see how many students are interested. That we'll see.
Yeah, sure.
So we'll join at 10:05. Just 5 minutes.
Yeah, sure, sir.
Asta, you have to introduce to Chinmay sir first, then we'll start. Okay.
Yes, sir. We now have the pleasure of welcoming Dr. Chinmay Kumar Dehri, Assistant Professor at the Department of Computer Science at IISER Berhampur. Dr. Dehri holds a PhD from Chang'an University, Taiwan, and has previously served as a researcher at the University of Tartu, Estonia. He is an accomplished scholar in cloud and fog computing, edge intelligence, and resilient distributed systems, areas critical in smart infrastructure. He leads cutting edge research on resource management, fault tolerance, IoT edge cloud synergy, and secure data pipelines, with publications in precious journals, IEEE, and JSAC. Please join me in warmly welcoming Dr. Dehri. Sir, we look forward to this insightful session with you on version control system using Git. Please, over to you, sir.
No, Chinmay sir, session is yours. Now I can control.
Yeah. Fine. Yes, thank you very much, Asta, for the nice introduction. And first of all, I'd like to thank the entire team, the entire organizing team, especially Dr. Satyanjan Das, who is actually, I know him since last probably 2013, 12, 13. So we are in touch, and then all the time, he's giving great opportunities, also great suggestions. I'd like to thank the entire team for organizing this nice event of 3 weeks in data-driven cybersecurity using Python. So without wasting more time, let's move on to the topic. So let me share my screen first. Okay. I hope now you can see my screen.
Yes, yes. Viju.
Yes, perfect. I hope nothing else in the screen.
No, no.
Okay, perfect. So already Asta already introduced mine. What I will do in this entire session, first today we'll discuss on version control system using Git. 1.5 hours. We'll try to cover around like 1 hour for theory, or maybe at max 1 hour for theory, and then around 30 minutes minimum we'll discuss. We'll give you a hands-on the demonstration. I'm not sure how much you're familiar with Git, how much you're familiar with the motivation behind Git, why Git introduced. That is much more important than just knowing what is Git. So for that, that's the reason why theory is much more essential um, in addition to the practical sessions. Uh, if you have any questions, probably like you can ask in between, or if you you can also just post a question, and then I'll try to answer that one as soon as possible. If I'm not able to, probably someone can help me if I'm not answering or if I don't see the chart, because I have only one screen. So I need to look at my slide, and at the same time, probably looking at the chart is not that convenient for me. But anyway, let's move on to the session. So we'll discuss about the version control system. And what we'll do, we'll also look at what the different VCS types, version control system types, the goals, different software tools, how Git is different from GitHub or GitLab or Bitbucket, and then few other concepts and configurations and installation, all those things. We'll quickly look at those things. We'll discuss also some of the Git concepts, for example, pulling, cloning, branching, forking, merging, rebase, and other things. So let's first look at in general, the idea. Whenever you try to develop any software application, any data-driven software application, what you do, you first create some file. And for the basic, for the easy understanding, let's take a very basic example. You create an HTML file, help.html. Let me, you create one file, let us say HTML file, help.html, and then you have something from some content you have. Now what do? You try to change that one. The moment you change that one, what you'll do, you'll probably create another file. One option is that you create another file just to preserve what was there in the previous version. Or what you do, you can simply overwrite the same file with the new content. But in that case, probably you will not have any storage, or you don't have any ways to go back to the previous version. So again, you change something, and you have again another version of the file. So what you do is that you create multiple versions. Either you have the same file with different versions, v1, v2, v3, v4, or you simply override that one, or you have some sort of other approach. But now question arises that if you're going to store each and every version, then how you're going to manage? So version control system, uh, which talks more about how you manage the different versions of your files. Because in the software, it's not only one or two files, it's like thousands of files. And it's not only you are working on those files. Again, thousands of experts, they are working on, collaboratively, they are working on the software development. That means like thousands of software experts, software engineers, working on thousands of file. Then how you manage the versions of each and every file. So the version control system, also known as a source control, is a practice of tracking and managing the changes to the software code. So even if like there is a single change in one letter, you should be able to say that this change was made in which version. So So when we talk about the manage changes, that means who created file, who edited the file, who saved the file, modified the file, or delete the file. And also, in addition to that, who did this one, for what purpose, at what time, and where. And that's what your source control or your version control system would be able to give you this kind of, or would be able to answer such kind of questions, that who made the changes, why made that change one was made, and what was the change, and when it was made, and for whom. So these are some of the questions that you can change or you can answer because of this version control system. So there are like two different types. One is local version. One is you have a local system or you have this centralized version control system. And the other one is a distributed version control system. So before it was like a local version control system, but like you are only working on your own laptop and no one has the access to that. And there is no, pretty much there is no good way to share those changes. So what the new concept is that you have the centralized version control system. That means all the codes, all the files, all the assets, all the data, everything will be in a central repository. And if you want to change anything, then you simply connect to that and then you make the changes. For example, your Google Doc. So Google Doc, what you do, you make the changes, and for that you need to be online. Of course, if you have the docx file, that's a different thing. But if it is a Google Doc, then you need to be online to make any changes. And that's what, like you have one file, one Google Doc, and at the same time, 5 different person can simply edit that single file. So irrespective of that, I mean, all the time you need to be online and you need to be dependent on this internet connections. To mitigate this issue, you come to the distributed version. What you do is that you have central repository, same like your centralized version. So you have a main server or a centralized repository. And then what you do, if you want to change anything, then you bring that copy to your local system. And with that local system, you work. So that means, though there is a there is a centralized version, you bring that one to your laptop or to your PC, and then you work on that. And this will be followed by all the persons, all the expert members, all the software engineers. So if once you are done with changing the file or changing the data, then you send that on to the centralized repository. So that means it is possible that the single file you copied, at the same time there is another software engineer who copied that one to the local system, and you both might be changing the same file in a local system. But the moment you both send that one to the central repository, at the time probably there will be some sort of conflict. But all those things we'll discuss that one later. So this is what the difference between your centralized version control system and distributed version control system. Nowadays, in more or less, most popular one is the distributed version control system. But still, the centralized version control system is in place in some of the places. Now, how you implement this one? And for example, if you have a file, still, I know there is some of the teams, what they do, each of them in the team, each of the member, they will simply edit one file and they will send it to the other person to edit, and then the second person will send that one to the third person to edit. So in that way, the whole team, they'll simply collaborate. But what we discussed just before, the version control system, when you implement that one, basically the good implementation is the Git. So Git is simply a software tool which implement the entire idea. And then what is the difference between GitHub and GitLab? Again, GitHub, GitLab, both of them, they rely on Git. So it's just a different version of Git. So for example, like GitHub and GitLab, they do simply provide Git over cloud. So you don't have to you don't have to set up the entire servers. You don't have to manage all these different repositories. The Git and GitHub and GitLab, they will simply implement, and they will allow you to simply put the file in, but other online technologies, online difficulties, they will handle. Uh, what we can say that GitHub and GitLab, those those solutions, they are simply providing Git over cloud or software as a solution. So some of the features, if you look at, more or less, we have discussed a lot of things. One is disaster recovery friendly. That means even if, because of a lot of replication, even if something happened to your local copy um, of your changes, even if that one crashes, but still you'll have some sort of some version of your code in the centralized repository. And Git also allows you to keep the complete history from the very beginning when you create the file from that point till now. A complete history it will give. It's also very fast and reliable. Of course, you may say, is there any alternate to Git? Yes, there are some alternate to Git. For example, source code management, there is SCM, there is also different version. Before that, also there was some sort of RCS or revision control system. It was something there. That's also a different concept, that how you manage the different versions. But Git is much more popular than others. So how you install Git is simply you go to Git SCM, or you simply Google install Git, or Git for Windows. Then you would be able to simply download that one. In most of the modern systems, Git is already pre-installed. At least for Linux, it is there. I believe also for Windows, I believe it is still there, but I'm not sure about that one. I'm not sure also about Mac OS, whether Git is pre-built or not. But with the recent version of Linux, you don't have to install by yourself. Rather, it's already there. So once it is installed, let's assume that this is installed. Um, So first you need to configure. So you need to understand, like, there are three different levels of configuration. One is the project level. So if you're working on multiple projects, so for each and every project, you may have a different configuration. Global level, that means the configuration is applicable to all the projects, but within the same user, only for that for the current user. There could be also configuration file for the entire system. That means it doesn't matter who is user log into the system or to their local PC, irrespective of that, you will be able to apply those configuration. But what are those in the configuration file? What kind of information you put? In the configuration file, you put what is the username, what is your name, what's the username, your or your credential files, and few other things. Uh, so the simple command is git config and then your username, without any flag. If you put, then it's simply just your user.name is the key, and this is the value of that other key. But if you want to put it in a global level, then it's just like your dash global. If you put this will basically indicate the level of configuration, and then same key and value. uh, Here also, instead of global, you can put system for the system level configuration. These are also the path where you can see, look at the configuration file. Of course, if you just provide the git config, then you will be able to see all the list of keys and values. So keys and values, for example, over here, user.name is the key, Chinmay Deori is the value. Similarly, you will also find user.email is the key, and then your email ID would be the value. So you can list all the configuration. You can also edit the configuration file. Yeah. So this is what. Okay, so what is the concept of repository? It's just your entire software application, right? So what you how actually it appear is that, let us say our GitLab, sorry, our repository is in GitLab, not in GitHub. Let us say it is in GitLab, but of course in the demo that time we'll use GitHub, not GitLab. So so the central repository, it will look like your https gitlab.iservpr.ac.in. Okay, it should be only one iservpr. So for the host, it could be also github.com. It could be. So this is your main server, and then your local one would be, so if this is the main server, your repository name could be gitlab.iservpr. So this is the host, and then this is my username, and this is the repository name. So when you bring a copy of this repository to your own system, then it will be stored somewhere, let us say in the D drive. Maybe it's in the D drive or C drive, wherever it is, It's entirely up to you where you keep that one. And you basically work on this repository. So this is what we call always the remote repository. So always keep in mind this technical term. So this is always called a remote repository, and this is the local repository. So when you need to bring that one, copy that one to the local system, at the time you can use git clone. So that means it assumes that your repository is there in the main server. It's also possible that you can create the repository on your local system first and then send that one back to the main server. But in most of the cases, usually the repositories are created in the main server, not in the local server for the first time. Usually created in the main server and then bring that one to the local system. That's in practice. So now when you make any changes, what usually happens is that you have different stages. So in different stages, let us say whenever you're trying to make you're modifying something, it's possible that the changes can be missed by mistake. It's not by intent. Okay, so that's why, like in the Git, there are three different areas or three different stages out there. One is a working directory, the other one is the staging area, and the last one is the Git directory. So whenever you make any changes or any file, that is first the working directory, and usually Git will not track that file whether there is any change or not. So you need to modify or you need to add the file to the staging area, and then once you add the files or the changes to the staging area, then you send that on to the Git directory. So let's take an example. So what you do first, let us say you create one directory, and then you make any changes. Also, you create a Git repository, and for that you can use simply Git and then initialize init. So this will basically initialize the empty Git repository in some sort of in your local drive. And then what you do after that, if you try to access or if you try to see what is the status of the Git repository, and then here you will see that no branch master, no commit yet, and nothing to commit. So all these things we'll discuss. But if you look at this one, after git init, you'll see there is something appearing over here with the name master. So this one basically represents that where actually we are working on. We'll discuss what is master over here. And then once you make any changes in the same folder or the directory, and after that, if you try to see what is the status of your Git repository, then you'll see that untracked files readme.md. So this is the file I just created over here in this command. So what you do over here is that it is saying that untracked files readme.md, and basically you need to, that means add that one to so that Git can track this file if there is any changes or not. And for that, you can use Git add and then your file name. So once you add that one, then it will go to the file will go to the staging area. So at this point, let's have a demo also. So this will basically help you. Let me first stop sharing. Okay. I hope you can see my screen. Okay, so what we'll do over here, let me clear this one first. Sorry. Oops. Mhm. Okay. So let me share the entire screen. That would be much better. Okay. So can you please confirm if you can see the screen enough, or do I need to increase the size?
Fine.
Okay. So first, let's create a folder. Let's say the folder is first repo. And then I'll go inside the folder, and then what I'll do, there is nothing inside the folder. So first repo, there is nothing. So any folder can be turned into a Git repository by issuing the command, execute the command git initialize. So that means now I'm instructing Git to consider this current folder as a Git repository. So for that, git init, and then here it is saying that initialize git empty Git repository in this folder. So what I'll do, if I say status, okay, there is nothing. Let's create a file and let's put something inside that file. Okay, I'm just giving some random content and first file.txt. Okay, so inside the first repo, I have a file first file.txt. And now again, you try to say what is the status of the Git. So here you can see the Git add. It is basically saying that there is one file which is not being tracked by Git. So that means right now you are in the working directory. The files are in the working directory. It is not in the staging area. So it needs to go to a staging area. Okay, so for that, what you need to do, git add and then first file.txt. So what you do over here, that again you try to see. So here you can see that, okay, no commit yet, but changes to be committed. At least now you don't see that there is a untracked file. So that means, and you can also see that there is a it is also instructing that this is a new file, first file.txt. So if you want to see what are the files, so right now you can see that you can say that first file is in the staging area, but it's not yet committed. So what do you mean by committed means, what I mean over here is that once you have some file in the staging area, after that it needs to go to the directory, sorry, git directory. So git directory is the, it's kind of, you are telling Git that please preserve the current version of my file. You are instructing the Git that please store the current version of my file. So in that case, what it will do, what are the changes we have made in the entire repository, it will take a copy and then it will store somewhere in an encrypted format in its own database, and it will say that it's one version. So when it will take all the files, all the changes that are present in the staging area, it will take only those files and it will store it in its database. And for that, what you need to do is to say git commit, and then you need to provide a message that what is that, what is the changes you have made. So what I will say over here, first version of the first file is done. Git commit, and then I have provided here. So this is the summary. So this is basically, you can say this is the purpose why that change is made, for what reason. And once you commit the changes, then you will see some alphanumeric characters, some DF44, CB4. So some alphanumeric characters you will see. So this is basically called the commit ID. So actually commit ID is not only this 7 characters length, rather it is actually 40 characters length. So 40 characters of alphanumeric characters. So, but in the short form, it's only giving the last 7 characters, not the entire 40 characters length. Now, if you look at the status, so in the status, you'll see that on branch master, nothing to commit, and working tree is clean. So you can at least see over here that there is no problem, and everything is in the right direction. Now, before moving on to the next one, let me see some of the chart. There is some questions. Okay. Okay, great. Okay, so I hope it is clear. It is clear now. The purpose of this dollar symbol. So let's go back to the theory. So usually what happened that whenever you make any changes at the time, Git always keep track of the recent version of your file. So it's possible that after a certain time, you might need to have, or you might have a lot of versions of the same file. But how Git will come to know that which version is the latest one and which version is the 5th one or 4th one or 6th one? So to know which version is the latest one, for that there is a pointer. It's just you recall the linked list. I hope like you know what is linked list, or the single linked list, double linked list, everything in the data structure, C and data structure. So Git, again, it simply create a pointer which will point to the first commit, sorry, to the latest commit of your version of your files. So that means it will point to the latest version of your file or files, everything. So yeah. So whenever you make any changes, again, the pointer will move from the first commit to the second commit, and accordingly, the more and more commits you make, the master branch or the pointer will simply move to the latest one. So that pointer, the name is the name of that pointer, usually we call it master. In some other cases, you will see that it is main. So main or master both are synonym basically. At the end, those are simply the pointers. It's just the naming convention is changed for certain reason. Now, so actually, if you look at multiple commits, so let us say over here right now, I had like only one changes. Let's make another changes in the first file. Let's open this one, and then this is the second line for another commit. So I made another changes. Now what I'll do is again I'll change. I'll see status. Again here it is saying that on branch master changes not staged. So not staged, again, that means it is saying that you need to add the changes to the staging area. So for that, you can say git add, and then that means what you need to do is first file.txt. But also there is a situation that you might change multiple files. So you don't have to add one after another. If you want to add all the changes to the staging area, what you can do, git add and then dot. Dot means the current directory, and then hit add. So once you enter this command, that means all the changes, whatever you have, everything will be added to the staging area. Now, after that, again, you see what's the status. Now you need to, you can see it is written as modified, it's not new file. But before it was written new file. But now it is written as a modified. So now what you need to do, commit /m, and then second version. So everything is changed. So now you can see that over here, this is another commit ID, which is completely different from the previous one. And over here, now what you have is you have two versions of the same file. And if you want to see the history, then you can see if you enter git log, then you will see what is the commit. So here you will see it's a 40 alphanumeric characters, but you don't see always enter all the 40s. Rather, you see only the first 7 or last 7 sometimes. I guess it's the first 7 characters it is showing. Is it 4? Yeah, it's the first 7 character it will show, and rest of the things will be truncated. So in this, what you will see, this is the latest one, and this is the first one. So in the latest one, you'll see a lot of different information, a lot of different varieties of information. One is the ID. Second, who is the author? That means who made these changes. And then what is the email ID? Of course, because I have already configured this one. That's why. And then when the change is made. So for example, over here it's the Friday, June 13, and this is the time, and this is also the time zone. So it's not only the time, because it's also the time zone it will record. Because it's possible that in your software development, in your team, it's not one person might be in a different time zone, other person might be in the other time zones. And this is basically the summary of your changes. So this is basically the summary of changes or the purpose, you can say. And similarly, you'll see the first commit. So you can see if you make 100 different changes, and if you enter git log, then you'll see all the changes or all the summary of changes. Okay, let's see, there is an, okay. So the difference between staging and commit is that, okay, so commit is something it will store, because the moment you say commit, that version of the file, a copy of that version of the file will be stored in the Git directory. So let me show you. So this is the current directory, and in the current directory, we have only one file. You see that only one file is there, right? But it's not actually one file. There are actually multiple folders are there. So if you look at, then there is something, a folder called .git. This is a hidden folder, and in this folder, all the different versions of the file is stored. So if you have 100 different versions of the file, that means you have executed 100 times git commit command. At the time, all the different copies will be stored inside this directory. So if you look at .git, then you will see a lot of different folders. And basically, object is the folder where actual copy of the file will be stored. So for example, if you want to see object, then you will see something 41, 51, 54. It's very difficult to know what actually these files are. But if you try to look at, or if you try to make a correlation, then you'll see the last commit. The first commit is df44, then 65.9e. Okay. Now you try to see df is here, and 65, I believe the recent commit, the first two character is 65. And here also you'll see 65. So every time whenever you make any commit, it will actually create a different folder inside based on the commit ID. And the commit ID is nothing but the hash of all the changes. So, okay, so now coming back to your question, that what is the difference between staging area and commit? So because you will be changing a lot of time, so what you do that every time you make any change, you say Git that please record these changes. Git will not record each and every changes. It will not record the moment you type some characters. Rather, it will track, or it will record only when there is any changes, and if you explicitly you insert Git to record their changes, then only it will record that one. But it will not store in the repository, or it will not store in the database. So it's a area where Git will say that even if you lose any changes, or even if you you make any changes, or even if you lose your file from the staging area, it will store the files to the commit or to the actual database. So this is just kind of a safe area where like it is possible that you're not going to do the commits all the time, right? So what you are doing is that you make changes, and then in between you are adding the changes to the staging area. And it's also possible that you don't want to store everything to the database. It's possible that out of 50 files, you want to store only, or you want to uh, put only 5 or 10 files in the staging area. So that kind of flexibility is also there. So staging area, it's kind of, you can say, a buffer area before sending the files to the database. Okay. Okay. Now coming back. So now you understand that what's the different stages of your changes. Now let's try to understand that what is branching. So now I have this repository. Now I have this repository, first repo. Now what will happen if I want another team member to also work on this one? So if you look at git log, sorry, there are like two changes. So from here onwards, it is possible that someone else will also work on the same project, or someone else will also work on the same file. Then in that case, it's difficult for Git to track who is making or who is working on which file. Okay, so for that, usually what will happen is that Git allows you to create a multiple branches. So what will happen? Let me move on to the slide. Yeah. So here, let us say these are different commits. Oops. Okay. I hope you see my screen. So let us say these are different commits. First commit, second commit, third commit, and fourth commit. At this point, let us say someone else want to start working on from this copy or from this version of your file. So what will happen is that at this point, you can say, okay, let's create a new branch. And for that, probably you can issue a command git branch and branch one. It's not exactly branch one, but always the name should be a meaningful one. For example, someone wants to start from, or someone wants to start working on the front end. Someone wants to start working on the back end. Someone wants to start working on the mobile version of the application, or Android version of the application, or iOS version of the application, or someone maybe wants to uh, start working on the recommendation system of that application or recommendation feature of that application. So based on the different context, the branch name should be a meaningful one. So let us say you want to create a new branch. So what actually will happen is that Git will create a new pointer similar to main or master. Git will create a new pointer, and then whenever you try to work on that, you'll always you'll always work on that same branch. So over here, what will happen is that once you create a branch, you check out to that branch. So that means the moment you say git check out branch one, that means you are instructing Git that I want to work on this branch. So now again question here arises that there are two pointers, main and branch one. So now how Git will come to know at certain point that on which branch you are working on. So for that, again, there is a new pointer called head. So head will basically tell you that on which pointer currently you are working on. So when you mention git checkout branch one, that means at the time Git will create a new pointer called head, and that head pointer will basically point to the branch one. So by default, head will point to main. So if you look at uh, the output over here, you see head is pointing to master. So this is a pointer. Head is a pointer. Master is also a pointer. Of course, over here right now we have only one branch, so that's why you see only one master branch is there. But it's possible that you may have multiple branches. So this is how Git knows how many branches are there and on which branch you are working on. Okay, so now let us say if you make any changes, when you are in the branch one, you make any changes, then Git will create again a different commit, and then the whole branch one will point to the latest commit. But the main pointer, this will remain pointing to the second recent commit. So now let us see over here git log all graph. Well, this will help you to see all the logs in a graphical format. Okay, there are some questions. Okay. Okay. What are the difference between hosting a website and working in cybersecurity through VCS? Okay, let me come to that point. I'll discuss that one. Let me point out. So right now for the basics, what I did is that I create the repository in the local system, but it's also possible that you can create the same. You can create the same in the GitHub or GitLab, and you can host your code over there. So let's move on to the branching. Okay, so here what we have is that you have different branches. So the moment you make any changes, what you do, your branch one or the pointer will move or will point to the latest commit, and head will remain always pointing to the branch one unless and until you change the checkout to main. Now let's have a quick demo. So what I'll do is git branch, and then let us say branch one. So what it is doing is that now it is creating a branch one. Now what I'll do is get checkout. Okay. So here you can see switch to branch one. Now let's make some changes. Git, sorry, echo changes in branch one. Okay. Now what I'll do, status. Okay. Git head, then git commit. Let us say I just commit with some summary. Okay. Now, if you look at git log, then you will see the recent change was made when head was pointing to branch one. So even now, actually, head is pointing to branch one. And then the second one, this one is showing that this commit was made in master. Of course, the rest of the things will be in the master. So if you look at, if you want to see in the graphical version, what is that? Hmm. Okay, so git log or then it will try to show you everything in the graphical version. Of course, there are like not many number of commits are there. That's why it's very difficult to see in graphical versions. But this is one command which will help you to look at in the graphical version different branches of your repositories. Okay, so now also there was question that what will happen if you host your file in the GitHub. Now let's go to GitHub. For that, maybe I can go to. So what you do is that first you log into your GitHub profile, and then over there you can look at the new repositories. So once I click on new, then I can say over here first repo.
We cannot see your browser.
Sorry.
Will you share your browser because we cannot see?
Oh, sorry. Let me. Give me a second. Can you see now?
Yes, now we can see. Thank you.
Okay, perfect. So what I was saying here is that, okay, once you log into your GitHub profile, then you click on a new button over here. And once you click on this new button, it will ask you what is the repository name. And let us say my first repository name, I'm giving something. And let us say I'm trying to do it in private, and keeping rest of the things to its default. I'll create the repository. So in this repository, there is nothing. So what I can do is either I can make the changes over here, or I can create the files over here, or I can basically download this repository to my local system. So in that case, what I can do is I can clone this one using git clone command. So what I'll do is, let us say, I will copy the URL of this repository, and then I'll copy and then I'll clone that onto my local system. So once it is there, let me first come out of this Git repository. Mhm. Okay, and this main. Now git clone, and then what I'll do is, okay, let me first copy this one. Okay, so what I did over here is that I copied that one, and the repository name is first repo underscore kit. So now whatever I want to do, I can make some changes over here. For example, like let us say, let's create some files inside that, some files.txt, and then again second file.txt, and then some random data, okay. So what I did over here is that I just created the files. I created the file. Let me go inside that folder or that repository. And if you look at the status, then you will see that yes, 2 files are created, but those are not being tracked. So you just add everything to the staging area. Now again, commit. So some changes made to the repo. Some random message I'm just giving, but it's actually not a random one. It should be something always a meaningful one. So what I did over here is that I created the repository in GitHub, and then I download that one using git clone command. And then what I'll do is, once I make some changes, obviously all these changes you will not be able to see in the repository. So if you look at here, still it's there. It's saying that there is no change. There is no, it's just an empty repository. So what you can do is, now you need to post this one to the remote one. But before that, let's first finish the clone. Yeah, pulling and cloning. So here you saw that I used git clone command, not git pull. Uh, Git pull is always necessary when you need to make some, or when you need to sync your changes with the remote one. So for example, because in the whole software, application, it's possible that before you make any changes or before you commit your changes, maybe your main branch is already have a lot of different changes. So at the time, sometimes you need to synchronize your version of the repository with the remote repository. And for that, usually git pull command is used. So basically you update the local copy with the new commits from the remote repositories. And this is what for that you use git pull command. So fork and merge, again, this is a different concept. Fork and merge, if you look at forking, it's basically someone is having a repository in his or her own account. You try to bring that one, you try to copy that one in the server itself. You try to copy that repository and you store that one in your account, inside your account. So that is what you're forking. It's a very layman term. That is the meaning of forking. Yeah. So that is what your forking is. But merging is like when you make some changes. Let us say, let's take this example where you have, you are working on branch one, and branch one is pointing to the latest one. So what you do is that now you go back to the master and again you make some changes. Okay, so if you make some changes, so basically like what you do over here is that when you are in the master, at the time you want to merge these two different branches. And basically in this case, your main will simply point to the latest commit. Because when main was here, or when your master branch was here, at the time you didn't make any change in the master branch. You made some changes in the branch one, but not in the master branch. So that's why now it is very easy to merge these two branches. But what will happen? Let us say when there was a commit, let us say C2, the commit ID is C2, and over here you create two branches. One is branch one, and when you are in the branch one, you create a new commit.c3. You create another commit called C5 when you are in the branch one. Now you go back to the master, and from here, when you are in the main branch or the master branch, you create some change or you make some changes, and then you create a commit called C4. Okay, so now here, if you see, your main branch is having some new content. Your branch one branch is having also some new content. Now what will happen? How will you merge these two things? Of course, when you merge, at the time the content will be merged. Let us say in C4 you have created a new file, only you created a new file, and in C5 you might have created some new files, or you might have added some new file or modified some existing files. At the time it will try to merge the contents of C4 and C5, and it will create a new branch called C6. And when you are merging, at the time when you are in the master branch, the content of C5 will be merged to C4 and a new commit will be created that is called C4. Sorry, C6. And your head will be pointing to the main or master branch. And this is also known as three-way merge. Sometimes it's possible that in C4 and C5, the same file, the same line is modified. At the time, that's called your merge conflict. And let's take an example of what is merge conflict. Let us say in C0, this is one commit, and in one file, there are like 4 different lines out there. You create a new branch and you make you made some changes, and let us say you change only the 4th line, and you create a commit that is let us say C1. And let us say from here also you create a new branch and you make the same line, that's the last line, you make some changes and you create a new commit C2. So if you look at C0 and if you compare with C1 and C2, in these two commits, you changes the same content, so the same line, same file. Now, if you simply merge these two things, obviously there will be a merge because Git doesn't know which line to keep. the first one, this is fourth line, this one, or this is not sixth line, this one. So at this point, this is a conflict, and this is what you need to do it manually, that which version of the file you want to keep, whether this is fourth line or this is not sixth line. Now it's up to you how you handle this one. So at the time, basically Git will allow you to edit the file in C3, and that time you can remove one of the file. Sorry, you can remove one of the line. This is fourth line or this is not sixth line. You can remove any one of them based on your requirement, and then you save the file. And then basically that is how you basically resolve the conflict. Okay, let's try to look at some of the demo. Let's see, there are some questions. Okay, let's come back to this question. You can host a website in GitHub, but for the cybersecurity you asked. Okay, the question was, what are the difference when hosting a website and working on cybersecurity through version control system? Irrespective of whether you are working on a data intensive work or data intensive application development or AI based application development or cybersecurity based AI development, VCS, or I believe this is Visual Studio Code you are talking about. Visual Studio Code is a IDE which allows you to also add some more flexibilities, some more capabilities. For example, when it comes to the cybersecurity at the time, if there is a feature and whether that feature is properly configured or not, for that you can have different extension in the Visual Studio Code. So the Visual Studio Code will help you to develop the code, at the same time scan the code in parallel. Of course, like if you go to a Sublime or any other text editor, then at the time probably you'll not be able to simultaneously develop the code and scan the code whether it is correct or not. At the same time, probably you'll not be able to do. There are also a number of extensions are there which will also help you to make sure that your code is secure enough. So it is nothing to do with whether you host the code in GitHub or in GitLab. If you host the code in GitHub, obviously the Visual Studio Code, it gives you or allows you to install a Git extension. For example, over here, if I look at the Git and okay, so if I look at the Git, which one is installed? I guess it's by default it's always installed Git. So when you have the Git installed or the Git extension is installed on your system at the time, it will graphically it will help you to synchronize your repository, to commit your changes, to make the changes or add the changes to the staging area. Also, it will help you to push the changes to the remote repository. So what are the difference when hosting a website and working cybersecurity through VCS? These two are completely two different things. I believe there is no major connection between these two things in terms of finding the similarities or finding the differences. Hosting the website in the website is of course hosting a website. It also involves the cybersecurity things, but working in cybersecurity through Visual Studio, irrespective of whether you work through Visual Studio or through any other IDE, doesn't matter. And hosting a website is just you are hosting the website also, which involves a lot of different security features which needs to be taken care. So I'm asking what's the difference when GitHub is hosting a site and the importance of GitHub in the cybersecurity. Okay. When GitHub is hosting a site, at the time it's just a different subdomain. I have not created any site on GitHub. There are like multiple features are there. First, you can basically keep the code inside the GitHub, and GitHub will recognize the code that you have stored, and using that code, it will host the website. So your code and your home, your website all are in the same ecosystem. That means you make any changes to the code, it will reflect directly to the website. Of course, probably for that you need to go for the premium subscription. But this is something possible when you keep the code and the hosting in the same place, in the same ecosystem. And now the importance of GitHub in the cybersecurity. Say from the security aspect, GitHub always scan the code. If there is any changes or if there is any misconfiguration, for example, you in the code itself you put any key or any password, at the time your GitHub will recognize that one. GitHub will also recognize any kind of configuration file which are uh, basically creating some sort of like vulnerabilities, or which are not good for from the security point of view. Sometimes it is possible that in a configuration file you open some port number which should not be opened. So some sensitive files are in the code itself which should not be there. So GitHub always scan the code all the time. But if you, let us say, host your website or your code in a different place, then you might need to install a different software tools to scan all the code from the security point of view. Website in VS Code can be writing and also bit of. Is there a way of preserving your old code and store it somewhere both locally and remote? Okay, I'll demonstrate this one now. So, so what I did over here is that I created the repository in GitHub. I cloned that onto my local system. Now what I did, I make the changes in the local system, but the changes are not yet reflected in the remote repository. So if you're using your VS Code, it is very easy to do that. So for example, over here, what I have is, this is the, okay, not this one. Okay, I made some mistake. I created this repository. Mhm. Let me see. Sorry, ls. Okay, it's here. Okay, so what I'll do is I'll see what the changes I made. Not this one. Okay, actually what I did is that I cloned the GitHub repository inside another repository on my local system, which I should not be doing that one. So what I need to do is I need to first remove this. So remove rf first repo underscore git, because this is the GitHub repository, and it is I created this one inside this repository, which I should not be doing that. So what I'll do, I'll come out of that GitHub. Okay, now I will okay. Now I will clone this one to my local system. Okay. What I'll do now is I'll create some file. First file. Sorry, let us say file1.txt, and similarly, let us say I'll create another file with some random content. Okay, now I will add everything. Sorry, again I made something this cd. I need to be inside this one. Okay. Okay, let us see. Yes. Git add, and then git commit. Some changes. Okay. Okay, so this is the repository. And I'll see. Okay, nothing over here, everything's clean. Now I will post this one. So if you're using VS Code, then you can see that first repo git, this is the repository. This is what I created in the remote. Right now it is not over here. Sorry, right now the changes are not reflected or not pushed to the remote repository. So what I'll do over here is that I'll simply synchronize this one. I'll make the commit, which is like it's already committed. Now I'll simply send that one or synchronize the changes. Now go to main. Sorry. Now post the code. So you don't have to write any command over here to make the changes or to synchronize. Now let's look at the GitHub repository. And over here we should have, so here you can see that file1 and file2, everything is here. So when you make some changes in the local and you send that one to the remote, all the changes, including the history, will also be stored in the remote repository. So when there is a question that, is there a way of preserving your old code and store it somewhere both locally and remotely before you pull? Before you pull, that means like, I mean, the moment you synchronize everything, all the history will be stored over there. So there is no question of like whether before you pull or whatever it is. It's a bit confusing what you mean by before you pull. But over here, it's basically that the changes, including your history, everything will store in the remote repository as well. Definitely, when you pull, you can decide whether you want to pull everything, all the history, or you want to keep some history, or you want to pull some history, not entire history. It's up to you. You can decide that one based on some sort of um, requirement or any kind of business strategy. So um, okay, so this is what some of the basics of what is this called? GitHub and Git. Now let me look at what are the other things if I missed. So okay, so now you know what is branching and what is create new. Okay, let's I have not demonstrated what is merge conflict. Let me demonstrate that one. So that will be our last demonstration, the demonstration of merge conflict. So let us say Okay, git log. Then here you see, okay, there is only one. What I'll do is I will git and then branch. Let us say B1 is the branch, and git checkout B1. So now I'm inside the B1. Now let's make some changes. Echo third file, file 3. Sorry. What I'll do over here is file 2. So in the file 2, the first line it is saying second file. Okay. So what I'll do is I'll make the changes. I'll say second file, or let us say I'll say this is not first file. So what I'll do now, this is not first file. Sorry, in file 2. So when I'm in branch 1, I said this is not first file. Now what I'll do, I'll go to again main branch. So git checkout, sorry, before that I need to make the commit. Git commit and just made, let us say. So when I'm in B1, I change the first line. I add that one to the staging and then I commit. Now I'll go to main branch. Okay. Now what I'll do, in the main branch, you can see automatically that I'm going back to the older version of the file. So what I'll do again over here is that I'll make some changes. Before what I was writing, what I wrote is that this is not the first file. Here I'll say, let us say, this is the first file. And add and same file added, modified. Okay. So here you can see that I'm in main branch. Sorry. I'm in main branch, and in main branch file 2 is written in the first line. This is the first file. Sorry. This is the first file. Okay. If I go to git checkout B1, in B1 automatically you will see this is not first file. So you can see the same file are changes are changed in the same line. Now if I want to combine or if I want to merge, then what I need to do? So first I'll go to checkout main. Okay. Now I'll merge the changes in branch B1, bring those changes to the branch main branch. So what I'll do, git merge B1. So here you can see auto merging file2.txt, conflict content, merge conflict in file 2, automatic merge failed, fixed conflict, and then commit the result. So in the file 2, if you look at head, this is the first file. This is not the first file. So this is the content from main branch, and this is the content from B1 branch. So now it's up to you which one you want to keep. So whether you want to keep the current one or the changes you made in the main, or you want to keep this one. Now it's up to you. So what you can do is you can remove the rest of the things and then reserve. Okay, sorry. Okay, so there is a merge conflict window is there. Okay, So this is not the first file, this is the first file. So you can accept this this current one, or you can do this one. So the result is first repo. So this is not the first file. So this is what I have kept, right? And now you can complete this merge. And once you complete this one, then you can give some, you can give some summary, which is automatically given merge branch B1, because again, main and B1 will be merged and a new commit will be created, right? So that for that new commit, you need to have some sort of message. So the changes are made, merge conflict is the conflict is merged and resolved. Now sync the changes. Once you sync, click on the sync changes, it will push all the changes to the remote one. So if I go back to my remote repository, GitHub repository, then here what I'll see in file. Okay. So if you look at this one here, you will see that there are two branches. View all, there should be two. No, why?
I think Chinmay sir, can you stop here? We can continue later at 12 o'clock.
It will take probably 2-3 minutes, and then probably this session will
Okay,
be
fine.
over.
So students are doing parallelly or not, you just check. They are doing or not. In the second half, you can ask the questions if they have any questions or students are doing or not. Okay,
yeah, it's more or less it's done.
Okay.
It's just like it will take 2 minutes.
Okay, fine.
Yeah. So if you go here, then okay, so this is not the first file, you have made the changes. And if you look at git status, okay, it is everything is clean. Now if you go to the branch over here, code, and then file 2, you see this is not the first file. So this is what we have. We merged this branch B1, and after merging and after resolving the conflict, we saw that this is not the first. I mean, we kept this line and we removed the previous line, right? And this is where, like, you can see that the history is also over here. Definitely, when you go to the code and when you click over here, you'll be able to see all the active branches. And if you click on this commit over here, then here you will be able to see all the different branches. For example, this one, merge branch B1. This is when we merge. And then some changes made, some file modified, some commits you can see over here. And over here you can see, so this is the first file. This is not the first file. This is where, like, in the B1 we kept. So this is what the basics of Git. Some of the basic concept of Git, for example, your branching, merging, resolving conflict. I guess rest of the things, okay. I guess rest of the things are some advanced stuff. Pulling, cloning, fork, merge, merge request. Okay, pull request and merge request is same, like when someone will send the request to apply the changes of the team member and merge the changes to the main branch. At the time, you use this pull request or merge request. So pull request and merge request is just a two different name, two different two different name, but the work is same, that merging the changes or applying the changes to the main branch. Yeah, so this is what all about the basics of your version control system. And in the next session, we'll discuss what is Docker, what is container, and the fundamentals of containers. We'll see.
Chinmay sir, few questions are in chat box. One or two, just try to
okay,
the answers. Yeah. Chat box, you can see some of the questions. One or two questions, just take. The second half, we can.
Yeah, I guess some of the answers also given. For example, some free domains provider. Apart from that, I just built a fully functional website with the advanced AI tools. How can I connect my website with some of these free domains provider? Okay, so that's a very specific question, slightly out of syllabus. I mean, not exactly out of syllabus, but currently for the current session, it'll be good if you can communicate later. Okay, attendance leak. I guess that's all. I guess rest of the things I have already answered. The previous questions already answered in between. If there is any other question, you are welcome to send me a post or send me a message, or in the second session
Yes, yes. Second session we can questions will discuss.
yeah, definitely.
Okay, okay. Again, we'll meet at 12 o'clock. Thank you. Thank you very much.
Yeah, sure. Bye bye.